the day.
Okay.
We request all the participants to please keep yourself on mute throughout the session. In case of any query, you can raise your hands. We request the participants to please keep yourself on mute. Dhaval sir, can we start the session? Dr. Dhaval, can we start the session? Is the voice audible?
Yes, Disha ma'am.
Yes.
We can hear you.
All right. All right. A very good afternoon to everyone. A very warm welcome again to the second day of our faculty development program. This program is on AI and data analysis for research. We definitely hope that you had a fruitful learning experience in the yesterday's session and you're already all set for today's enriching session ahead. Today, we are very delighted to begin our session on research problem identification and AI application. Well, it will help us to understand that how artificial intelligence can aid in framing relevant and impactful research problems, open up new dimensions in this research exploration. And today it is our privilege to welcome our resource person. He is very distinguished, Dr. Dhaval Mehta. To be briefing about his profile, Dr. Mehta is a doctorate in management and currently he's working as a professor in the Department of Business and Industrial Management in Veer Narmad South Gujarat University, Surat. He has almost 20 years of PG teaching experience, and he is having an industrial experience also of working in the multinational finance corporations like ICICI and HDFC Limited. He specialized in teaching quantitative methods, FM, production management, research methodology, and derivatives. Dr. Dhaval has presented around 40 research papers in national and international conferences. He has completed his minor research on stock exchange, supply money on stock exchange. He has published many books on Minitab software, statistical analysis using R software, machine learning uses R, RATL, data analysis using R. He is running his YouTube channel on the name of Dhaval Mehta for the young researchers like us, data scientists, faculties, and students. And this tutorial sessions of research is completely free, available on YouTube. Dr. Dhaval is a key resource person for many research methodology workshops, which is organized by various NITs, IIMs, and he has trained over 10,000 faculties, professional, bureaucrats, and various software-related conferences and sessions. He has organized FDPs on data analysis, SPSS, StratCraft, Stata, R Studio, Minitab, Jamovi, Excel, Power BI, Desktop, Google Data Studio, Tableau, SPSS, Amos, Edanco, Smart PLS, SAM is R, qualitative analysis and quantitative analysis using NVivo and Atlas TI. IT, designs of experiment using Minitab and design experiment, eViews, Gretel, econometrics using R, meta-analysis using R, and bibliometric, Biblioshiny, VosViewer, and whatnot. Overall, Dr. Dhaval Mehta is an accomplished professor, and he has an extensive experience in research, teaching, and training. So today we are looking forward to his valuable insights on this field. And let's begin our today's session. Over to you, Dhaval, sir.
Just give me 1 minute, huh? Starting the session, sharing the screen with all of you. Please confirm.
Yes, sir, you are audible, but we cannot see you.
Yeah, I'm sharing a screen.
Yeah. So even your camera is not on, I think.
The camera is, the lights are not there. Anyway, I can start the camera. I don't
All
mind.
All
The
right.
lights are not there. Anyway, just.
Sir, by any case, we would like to ask, is it your birthday today, sir?
Yeah, it's my birthday.
Sir, we, on behalf of MIT Business School, MIT University Chhattisgarh, we all would like to wish you a very happy birthday and auspicious day today. It's very good to share this day with you. Thank you so much, sir.
Thank you. Thank you. Thank you. I will start the screen, but the lights are not there. Anyway, wait a minute.
So the PPT is visible, the voice is audible.
Okay. Is it necessary, compulsory to keep the camera on, or I can?
You can keep it off, sir.
Okay, thank you. So the topic is literature review using AI tools. 7 steps are there. And the first step is how to explore thrust areas in your desired field of research. It will be completely an hands-on training. Make sure you are having good internet connectivity, and we start with the first AI tool, and that is Open Knowledge Maps. Start. All of you start accessing. Any case, if you face a problem, tell me. Click on it. Now, right down here, throughout the lecture, the term will remain same. So customer relationship management, go. Done? Now, when you click on any one of the cluster, it will zoom and you will be able to get a very specific paper on right hand side. Just click on it and you will get the paper. Just see here. These papers will be very specific to your domain. From here, the paper can be downloaded, press download, and paper is with you on the right hand side. Right? Done? Are you able to do? Please confirm. Please write in the chat box, are you able to do it or not? Right? So first, we will only try to find out the thrust areas, trending areas in which the research is going on. Then we will finalize the gap using the AI tool. We will finalize the title for the new study. Then we will start summarizing the papers. Using AI tool is just not writing just not writing. It has been used for many things like finding an anchor paper, seed paper, base paper, all this. So next AI tool which we have to see is Carrot Square. Carrot Square. Done.
Oh.
Carrot Square. Click here. Organizers, can you please take care of this matter? Carrot Square. Are you able to get it? Just please confirm anybody has got it or it is a problem in my side only. Anybody got the result in Carrot Square? Please confirm. Got it. Okay, fine. So that's a problem from my side. So you must be getting this type of window. Got it? Just check. Did you got it?
Yes, sir.
Now write in this customer relationship management. And there will be the clustering of the documents. You did yesterday also. With whom? Yeah, with whom? Gurmeet Kaur? I'm not getting it. You did this tool with someone else also, Gurmeet ji? Mrs. Srivastava. Okay, fine. No problem. So you'll get a tree map here. And the pie chart. Got it? So it gives me the core areas and the peripheral areas, right? It gives me the core areas and peripheral areas. Now, the next AI tool is Popexlity. The next AI, see, basically, don't use these tools in isolations. Maintain the entire pipeline. The next AI tool is Paperity AI. Paperity AI. Done? Is it working? Paperity, is it working? Hello?
Yes, sir.
Just a minute. My internet is unstable. That's the reason it's creating a problem. Just a minute. In case if it's not working, see what you'll have to do. Listen, side you must be able to filters. Some filters will be visible. So here, there you can specify the years for which you require a paper, the journal, the language, and click on any one title, and you will be able to download it very easily. Just check, is it working? Just click on any one paper and you'll be able to download the paper very fast. Try it. Okay, next. At present, we are just focusing on how to get the good papers. Now, next thing is to download, publish or perish. Enter. Click here. Now click here, Windows, right? Possibly, listen, you might get such type of error. Okay, no need to worry. Listen, all of you, how many of you got such type of page 403 forbidden? How many of you have got this type of page when you're trying to use publish or perish? Just confirm it. Okay, then what you should do? Listen, you go here and publish or perish, soft tonic. Here, click on soft tonic and free download. Yeah, click on this soft tonic and free download from here, free download for Windows. Run the exe file, and I'm waiting for all of you. You should get this screen, publish or perish. You should get this screen. Waiting for all of you. Done? Got it? Got such screen? Please confirm. Publisher Paris got this screen. It's very simple from Softonic. You run this. No. Okay, no problem. Did you got it from, see, I'll send you the website. From here, just you have to run the, you have to download the exe file. Take this. Done? The window is not coming. The window will come when you will see here, right here in search, publish or perish. The window will appear and click on this H symbol, and then you will get this screen. Kedarji, just try. If Microsoft Defender is on running this, I'm put you no need to worry. There is no problem. It's a very authentic exe file developed by one professor only. Trust me, nothing will happen. Say yes, go ahead. Nothing will happen. Trust me. Click on it and go ahead. Okay, now let's start. Let's start this AI app. From here, I can activate Google Scholar and write in the keywords customer relationship management. Specify the years here, 2015 to 2025. Search. Got the results? Are you getting such type of results? Please confirm and cross this here. Please confirm, did you got this result or not such results? Now this tool, okay, here on Softonic website, Minu Swarup, on Softonic website, Herzing software is there. Softonic is not a software, it's a website on which Herzing is there. Minu Swarup. Okay, now I can arrange the paper on the basis of citations. Click here. So citations per year. Now go on the flag and click 1, 2. Wherever you get PDF, see here the PDF is there. Stop. Stop there. Wherever the PDF is there, stop. Go at the bottom, open full text version and the paper will be with you. Check. Did you got the paper? Please check. Did you got the paper? All those who were able to download the paper. Okay, are you able to download the paper? Please confirm. Any repetition required? See, it is very simple. You click here and type on the top, wherever you get PDF, stop. Now select a single paper, open full text version and the paper is with you. Done? Is it done?
So please, can you please repeat
From
from
where
beginning?
From the beginning. Your software is ready with you now, ma'am? Software is ready?
Yes, sir.
Okay.
Yes, sir.
Right here, publish or perish. You will get such type of screen. Got it? Just check. Got this screen?
This
Here,
window I am not able to get. This window, Excel sheet, I am not able to.
share your screen. Share your
Okay.
screen.
Just a minute. This is the window.
No, you have not still downloaded the software.
Where this one?
Yeah,
Here
yeah.
only, no?
No.
Yeah.
Just a bit. It was at the bottom. Click on it. Yeah, here.
Okay. I'll download from here. No, this is not this one. This one.
No, this one. Yeah, this one.
This is coming. Download is ready to install. Here one.
Yeah, on the right hand side. See on the top.
This one.
No. On the top, the down arrow is there. No, see, enter passphrase you have written. Enter passphrase your on the top browser window.
Here.
No, this side.
Here.
Check in downloads. Click there.
Okay.
Right.
Okay.
Now run this. No, not that one. Not that one. Don't worry. We are with you. Don't worry. Here, publish or Paris, where it is written, no, publish or Paris. Yeah.
Yeah,
Run.
this one, no?
Yeah, run it. Now run it. Okay, run it.
Okay, I got it.
I agree. Install. Finish. Okay, now go at the bottom and write publish or perish. No, not there. Yeah, here is it. Ready. You are ready to work.
Okay,
right?
thank you. I got it.
Okay, it's very simple, right? It's very simple. Now you have to write here, activate the Google Scholar. Activate the Google Scholar from here. There will be a tab. And
where is that Google Scholar? You want? Okay.
Okay, and write in the keyword customer.
Suppose point of says digital.
Can you mute yourself, sir? Can you mute yourself, sir? Okay. So 2015 to 2025, you have to specify the years. Now, how much results you want? Search, done. And it will start connecting to the servers, and it will start. The papers will be given in the link, not here. The papers will be in the link, right? My antivirus detected Trojan virus. No, not at all. There is no virus. There is no Trojan virus in this. Possibly you must have gone through the another thing. It is a very authentic. I'm using it from at least 10 years through Softonic. At least 10 years. It has been developed by. My screen is sad only. Again, I am sharing it. Okay, see this. Now click here. 1. The papers will be arranged in the descending order. Citations per year. Now click here. 1, 2. Wherever you get PDF, stop. Wherever you get PDF, stop. Open full text version. Just click here. Open full text version and the paper will be with you. Done? You can get the Scopus provided that your institute is having a library access to this. So it will work as a front end. It will work as a front end. There is no problem. See here. I'll click here. Sorry, I'll click here. Scopus. When I click on it, it asks for the API key. This API key. If your library is having an API key, you will be able to work. You will be able to use this, right? Clear? This key will be with the librarian, provided that your institute is providing it. It will work as a front end. Now, this is not only the use of publish or Paris. I want to do something more. On right hand side, save results as BibTeX. Click here. Save results as BibTeX. Click here and press save. And press save. Okay, press save. Done. So it will be saved as pop sites. Here is it. Pop sites. Now, don't try to open this with either Word, Excel, PowerPoint. Don't try to open it. Keep the things as it is. This we will connect with the another AI tool. See what the logic is. This paper, okay, this paper, I want to find out its reference papers also by some AI tool. So we will see the another AI tool. Yes, Dr. Asutosh, tell me what's the question. Yes, Dr. Asutosh, tell me what's the question. Please repeat if possible. Yeah, I'll repeat it. No need to worry. Go here, save results. Save results as BibTeX. Not copy. Save results as BibTeX. Done. It will be saved as pop sites. Okay, the next AI tool. Be with me. So which are the AI tools which we have accessed? Can anybody summarize? Anybody summarize? Still you require repetition, Dr. Asutosh? Dr. Asutosh, still you require?
It's okay, sir. Thank you.
Okay, fine. No problem. If you want a repetition, don't worry. I'm there with you.
Sure.
Okay, we started with open knowledge maps. Yes. Then we did Carrot Square 2. Then Paperity 3. This is Publisher Paris 4. Next is Citation Jacko. Citation Jacko. Write down.
अच्छा
So the next thing which we are going to see is a Citation Jacko. Click on it. And click on Start Discovering Papers. Just can you recall that what thing we will connect here in BibTeX? What is the thing which we will connect here in BibTeX? Anybody can they recall? The file which was downloaded from Publisher Paris. Now click on Search for Papers and again right here Customer Relationship Management and put it in the search mode. Put it in the search mode. Now click here on the title and click on add selected as a seed paper. And as soon as it gets activated, click outside this box. Now let's understand this. This yellow are your seed papers and this black one are the reference papers. When I click on any one of them, it will give me the connectivity. See this connectivity. That in this particular paper, these are the references which have been used. Okay, I can convert this 2D plot into 3D plot from here. Just click on it and entire galaxy of customer relationship management will appear. Is it appearing? Just check. Is it appearing? Just check. Click on 3D. Got it or not? Please confirm in the chat box. All of you just click on this black dot. Click on this black dot here, any black dot, and if a white icon appears, it means that you will be able to access that paper. See, this white color icon will appear and you'll be able to paper. Right? Done? Just check it.
वो ठंडी बरसात में
Done? Are you able to access the paper? Please confirm. Hello.
Yes, sir, we can access.
See any black dot which is there, any black dot, right? Click here and it is asking me the connection, otherwise you will be able to get it. Okay. In case if you are not able to access the paper, what you should do, you should note down the DOI of the paper and the title of the paper, which we are going to see later on, how we will be using it. Okay. Next AI tool. This is citation Jackpot. Next AI tool is Heuristica. Heuristica AI. I think that there is some problem which I'm getting it. Wait a minute. Okay. Heuristica. Click here. Log in inside, and then you will get a get started button. Get started. So I'm waiting for all of you. You should get started button and click on it. It's a, you will have to sign in only one time. Get started button. Now right here, customer relationship management. Got it? And press explore. Got this? Please confirm. Got this tab? In center, you write whatever title which you are searching for right there. With me, all of you? Yeah, asking to log in, do the login. It's safe. Do the login. Provide your email ID. It's safe, and there will not be any spam or any bombarding of the from their side. Please take care of. Got this page? Please write in the chat box. Did you got this page? Okay. And it will start writing. Just click here, add to concept map. Pin it. Again, activate this and origin of customer relationship management. Pin it. Just how you want the things to be represented. Add to concept map. Click here. Now there are two options which are available. Again, customer relationship management. From this, I want to develop some concepts for my LR. Click here and related concepts, which you should take care in your research. All the related concepts will appear. So customer experience management, add. So the concept building has started. Now, again, I can elaborate. Give me the example of customer experience management. Add to concept map. Right, done. Now there is one provision of joining. Let's say I want to join this with this. So I can join from here. Or there is still one more provision. I can click here and split. It will be splitted. See, it will be splitted. Yeah, you go for try option. If you don't want to sign, you start with try option. Okay. Now I want to see the significance of this. Again, click here. Significance. Which significance I want? So I want to see the theoretical significance. Run. Add to concept map, done. Now I will copy this from here. See, just see carefully, all of you, just see carefully. These are the 3 dots are there. Copy to clipboard. Okay, copy to clipboard, go here and Control V, done. The text is ready. Are you able to copy? Are you able to copy or not? Please confirm. See, it's very simple. Go here, click on this 3 dots, copy to clipboard and press Control V. Go here, copy to clipboard, go in the Word file, press Control V. Done? All those who are able to do, please write done. So Gurmeet Kaur has cleared this. Very nice. Ekta Mishra, Richa Gupta, Arabi Fatima, Mohsin Mohammed. Very nice. Excellent. Kedar, Tisha, Archana Dubey. Okay. Any AI tool for which you require repetition, just tell me. Any AI tool for you require repetition. Any AI tool. Anybody? Any AI tool for which you require repetition. We have done open knowledge maps. We have done Carrot Square, Paperity, Carrot. Okay. Let me see now. Am I able to access? Can you use it? Yes, you can use it. You can use it. That's the reason you can use it for the paraphrasing. Yeah. So it's ready. Customer relationship management. Carrot Square, customer relationship management, search. So here you will get so I have generated it so many times, so it's giving me just that you have used it so many times, otherwise nothing. It's a Carrot Square. Okay. We can use this contain as it is, should be paraphrased before. You should always paraphrase before. Any AI generated content should be always paraphrased, always. Okay, next is next AI tool is Answer This. Recently, it has gained a lot of popularity. Answer This. If you are talking about ChatGPT, Jenny, these are all obsolete tools. Every year, the new AI tools emerge. The 2025, the most promising AI tool is Answer This of 2025. It has got some features, built-in features, which are only available in this particular. So we start with sign in. You can sign it with your Gmail ID. Done. Now right here, customer relationship management. Enter. Of course, it's a paid one, but its features are amazing. Those who want to write papers on bibliometric analysis, the only destination after BiblioShiny, the only destination. You can take for 1 month write a good paper on bibliometric analysis. Not a single command is necessary, not a single command. Got the result? Got the result? Just confirm, all of you. Now see, it's so interesting. I can chat with the individual paper, chat, right? So I can write here, PDF is available. Now, this paper will get open here and I'll post here, summarize this paper, and it will start generating the summary. Got the summary? Anybody got the summary? Anyway, you can do it from here. Now let's go back on the main window. So here is a summary of the paper. See, entire summary it has written. Summarize this paper. Okay. Again, we'll go back on the main window. See, many scholars are insisted that you give your literature review in table view. This can generate a table view. See, source information, extracted source, right? It will give you the table information. This can be exported in CSV as well as big text format. Okay. It can give me the bibliometric analysis of the selected papers. So what I'll have to do, I'll have to select at least 2 or 3 papers and do the bibliometric analysis. Done. publications per year, citations by year, combined publications and citations impact, title word cloud, abstract word cloud, top terms, top authors, author impact. And this can be downloaded. Just click here and your graph is ready. See, you don't require any R, commander, nothing. Just one click, done. Anybody able to do? Anybody able to do? Of course, it's a
So
paid
please,
one. But,
the-
huh?
this one. So please, can you repeat this one?
Yeah, just click on right hand side. Select 2, 3 papers and click on bibliometric analysis. Recently, they've added this feature. And I'll do it again. Sir, at how much paper can be done bibliometric analysis? Sir, at how much paper? Ariba, your question is not clear. What is your question? Just please elaborate. Sir, at how much paper? From this side, many papers. Just you have to go on tick marking and it will do n number of papers. There is no limitation. Okay, here you have to click here, bibliometric analysis. Here, and it will do. And make sure that at least you select 2, 3. Yes, Gurmeet Kaur, you can mention in your paper that this AI tool has been used. The policies of the journal have been changed. Yes, the policies of the journal have been changed, and you can specify that to generate the charts as well as to generate the trends, this AI tool has been used. No problem in it. There is nothing wrong in using AI tool. First of all, understand this. There is a complete misconception about there is nothing wrong in it. Understand, if you just mention in your paper that this AI tool has been used for doing a bibliometric analysis, there is no problem. In fact, was viewer, if I don't give the any name what it is generating a chart. Similarly, this is also generating a charts, right? So don't have any hesitance or reluctance that I will not use the AI tool. Okay, let's proceed. Now, this is also having some new tools like research gap finder, very unique tool, which is a research gap finder. And right here, that which are the areas in which I can do the relation if my intention is customer relationship management, done. So it will give me the research gap finder.
Where is this research finder menu?
Sir, on the left hand side, tools, just see the tools. Citation Gecko is used for finding the reference papers, converting 2D into 3D. Heuristica is to find out, build the concepts for your thesis, the initial pages of LR, concept building. You will get the best concepts from here. If you are missing any part, yeah, research gap finder. Of course, it's a paid one. I know it's a paid one. I know it. Here in tools. Till this thing is processing, let's go on the another AI tool. Let it process. Insightful AI. Often I get a query that is there any method to find out the appropriate journal where I should target on the basis of my title? Yes, here is it. Insightful AI. Spelling is INCIT, not SIGST. Okay. So customer relationship management. Enter. See, it has given me the gaps in which I can carry out the study. All the gaps. And based on the gaps which have been identified, which paper you should be studying. So if I click here on right hand side, it will tell me the paper. That use these papers. Okay. Use these papers. If you zero down on this research gap, these are the key papers from which the work can be started. Okay, so what we did, we found out the thrust areas from Open Knowledge Map, from Carrot Square. Again, we found out the thrust areas. Then from Paperity, we found the papers, publish or perish, paper with reference. This we connected in Citation Gecko to find out the reference paper. We landed up here to find out the research gap, to do the bibliometric analysis, to identify the research gap. And on the basis of, let's say this is my research gap. So which are the 5 major or 6 major papers which will be inspiring my research. So click on any one of them and you'll be able to download the paper, chat on it, abstract, everything is available. Okay. Now you don't need to search separately that this is my research gap, give me the paper. No. Gap and papers. Done. Now, in Insightful AI, view the graph. Click here. Scroll. See what information it gives me. There are 3 types of papers. One is base paper. Then we are having anchor paper. And then we are having seed papers. Anybody can tell me the difference between these 3 paper? Base paper, anchor paper, and seed paper. What is the difference? Yeah, anybody can tell me the difference? No problem. Yeah, yes, Apurva Mishra, I'm starting again. No problem. I'm starting it again. No problem. Okay. Now let's see the difference between this one. Base paper is having a historical relevance, that a particular model was discussed in 1980. It's having an historical relevance. Anchor paper is the most influential paper or the most inspiring paper from which you have carved out your research gap. And seed papers are those papers which build up the blocks of your literature review. Basically, these are all your reference papers. Okay. So this tool will help you to find out the base paper, the anchor paper, and seed papers also. So write down here customer relationship management. One more pipeline created. View the graph. Done. Can you see this paper? A conceptual model of service quality and its implication for future research. It suggests you that if you are working in customer relationship management, see the publication here. Don't miss this paper because it is a base paper. Okay. It will also give you the most important papers which your thesis should not miss on the basis of citation. 2, the most important recent paper which are being published recently. Okay, 2023, 2024. Normally, there is always a problem that you have not used the recent papers, all recent papers. Okay, next, top authors which are working in this genre, upcoming authors in this genre, institutions which are working, top journals which are working, similar journals which are working. Now, on the next page, just write down on one page, all of you, just write down on one page that these are the 3 authors whose work we require. Are you with me? Say yes or no. These are the 3 people whose papers I require. Okay, so now connecting this AI tool with the another AI tool, or I want the papers of, let's say, Robert Luce or Christian Gronos. Done? Are you with me? Shall I repeat? From where I have to repeat?
We are with you, sir.
From where huh?
Yes, yes, sir. Following, sir.
With you, sir. We can proceed.
No, there was a comment from someone. Archana Dubey, are you clear with me? Are you clear? Or you require a repetition? See, see what I am saying is, you select one paper, and it will give you the base paper, the historical relevance paper. Okay, where the concept was discussed first time. Difference between base is having an historical relevance. Anchor paper is a very recently published paper. Possibly it must be having some gaps on which you want to do a further research. Anchor paper is the paper which inspires you or from which you have identified the gap. And seed papers are all those papers. These are seed papers. This becomes your seed. All black dots, these are all reference papers, becomes your seed papers. And that's the reason on the top it is given papers citing seed papers. Clear? Are you able to understand how we are connecting the AI tools? Say yes or no in the chat box. Okay. Using AI tool is not Gen AI. It is not only one particular thing. Entire pipeline you will understand. Okay, let's proceed further. So it's a similar paper, most important paper, review papers, top authors, most important recent paper. You note down the name of at least 1 or 2 or 3 authors in this area. Okay. And I want only the work of these people. Okay. I only want the work of this paper. Click on it. All the papers are available. Done. All the papers are available. Right. But if you want to download any one of them, this site will not do that. This will not do that. Okay, institutions which are working in this area, top journals where you can target your paper, similar journals where you can target your paper. Done. Now you enter into Rabbit, Research Rabbit. Get ready. Research Rabbit. Research Rabbit is also not, you have to not to understand in the isolation. It is also we are going to correct something here also. Click here. So do the login first time, provide all your credentials, your name, your designation, everything. Okay. Okay. Now, this type of screen you should get. Wait a minute. All those who have got this type of screens, got it? Please confirm. Got it? Now, can you say something here, BibTeX? What thing I can connect here? BibTeX. What is the thing I can connect here? BibTeX. What is the thing I can connect here? Yeah, the output from publisher Paris can be connected here, which we had stored earlier. Very perfect. Archana ma'am, Apurva, perfect, perfect. Okay. Independent search can also be carried out. So write down here, customer relationship management. Enter. Enter. Now, read the title and the abstract. It just works like Amazon. Based on your papers selected, it will do the remaining work for you. So it will give you the suggestions that if you are interested in this product, why don't you buy this product? So add to collection 1. Scroll. Now pick up another paper. Is this interesting? No. Add to collection. Yes, no, that way you have to go and add to collection. At least select 3 papers. 3 papers. And click outside this box here. 1, 2, 3. 3 papers have appeared. Done. Please confirm. 3 papers have appeared. Please confirm. Is it done? Done. Please say yes or no and increase your attention level. Now we will do something meaningful. There is always a problem discussed by the scholars that ChatGPT gives a wrong citation. We will do it very scientifically, very ethically, use of ChatGPT. Okay, ethical use of ChatGPT. Get ready. See, based on this 1, 2, and 3, it will suggest me the similar work. Click here. All the similar works will be extracted according to the timeline. So there is one paper in 1997. This 1, 2, 3 becomes your anchor paper, and these are all your seed papers, right? Now click on any one node any one node. If the PDF is available, it will notify me. See, it gives me the notification that the PDF is available. Do you want? Yes, I want it. Download it. Done. So a paper from good quality journal with me. See, very good quality journal. Done. Okay. Next, what you have to do, just see carefully. Next, first of all, close this. Close this. Papers, this authors, and at the bottom there is a CSV. Just click once, and all the papers with the DOI, title, full information is with you on your desktop. Done? Is it done? Please confirm. You have to click on this CSV here. Done? Yeah, it's simple. See, here you have extracted this. Here, just click on this CSV. Okay. Now, go in ChatGPT. Done. Activate the ChatGPT. Search with ChatGPT. Okay. With me? Say yes or no. With me? Say
Yes.
yes if you are with me. Small y. Increase your attention level. We want to teach you. Increase your attention level. So that you don't miss anything.
Yes.
Press this plus sign. Add photos and files. And connect this research rabbit. Connect this research rabbit here. Open. Done. Now right here, based on the uploaded Excel, write the literature review in argumentative mode. Enter. Now there are no chances that it will give you a wrong citations. Okay. Possibly today I have used it. Anybody got the result? Please confirm. See this. All authentic citations will be picked up from Excel. Done. You are having DOI. There are no chances that it will hallucinate. Done. Is my screen visible? Hello. Is my screen visible or not?
No, sir, we can't see your screen.
Yeah, wait a minute. Sharing the screen again with you. Now, this is my channel dedicated for the researchers, okay, working in any social science, machine learning, or artificial intelligence. You go in the playlist and you will find the videos on everything is free. You don't have to pay single penny here, nothing. Stata videos soon we are uploading, bibliometric analysis 13 videos, structural equation modeling using Jamovi 11 videos, advanced data analysis using SPSS 70, machine learning using Orange 101, IBM Simplex Optimization Studio 6, Max Curia 51, prompt engineering, those who want to learn 21, generative 12, econometric analysis using R 25, qualitative data analysis using Atlas.ti 37, AI tools for researchers 68, Power BI 132, Excel 102, Alteryx 31, structural equation using Amos 32, 9, 139, Tableau 100, Smart PLS 39, Adenco 8, Python 15, Basic SPSS 48, Jamovi 26. I'm sending YouTube link, everything I'm sending. Panel data 25, RapidMiner 70, time series analysis using use 12. R&R Studio, my book on R&R Studio is available on Amazon. Qualitative data in NVivo. So 3 software I teach: NVivo, Atlas.ti, and Max Curia. Now there is a concept, something which is known as a Dhaval Mehta groups, right? So if you want to join this group, see, totally there are 13 DM groups and more than 14,000 faculties, corporates, NGOs have joined. So if you want to join to get the notification of upcoming workshops, you can post your workshops also. I have posted the link in the Zoom chat box. Okay, kindly join in it. Okay, see, there is a link. There is a link in the Zoom chat box also. And I am sending the link on your okay, now sending the link of my YouTube channel. So here is a link of my YouTube channel, done. Take it. Moreover, you will find my book on R. It consists of total 23 chapters, 500-page book, available on Amazon. The book has been written in such a way that the first chapter of this book is in sync. The first chapter of this book is in sync with this tutorial here. So you can see the tutorial, you can use the book. So video is available as well as the code is available. Apart from this, I'm sending my email ID, LinkedIn profile, and thank you for inviting me. Thank you, and starting the screen. I hope you all enjoyed the sessions. Thank you very much. Thank you.
Sir,
Skyspace. Tomorrow we are going to discuss Deepika Datsena. That tomorrow we are going to discuss. No, on 31st we are going to discuss about the remaining part, user how to do the data analysis using AI tool. Even if I don't know any command, even if I don't know SPSS, still how to intelligently submit my work, create my work, right? Thank you. I hope you all enjoyed the session.
okay,
Thank you. Over to you. Sure, sure. I'll share it. Just a minute. I'll share the prompt also. Wait a minute. Somebody. In research, I don't believe in any monopolies, and I believe in giving it to the new researcher. Take it. Okay. Okay. Over to you. Yes, organizers, over to you.
Yes, sir. Uh, Thank you so much, sir. If there is someone from the participant who would like to ask any question from sir, please raise your hand to ask any question.
Thank you. Thank you. Thank you,
So can
Priya.
we have 5 more minutes for the question if there is any?
I don't mind. Go ahead.
Yes. All right. If anyone from the participants would like to ask some question. I guess, sir, all the participants are pretty much clear with the concepts that we have discussed, that you have discussed with them, sir. So thank you so much, sir. Thank you for giving your time and such a valuable insights on the topic, which is very novel to us. And thank you for introducing us to such aspects of AI. And we again thank you from the behalf of MIT Business School, MIT University, Chhattisgarh. And again, I would like to wish you a very happy birthday, sir, and enjoy your day, sir. Thank you so much for your time.
Thank you. Thank you for inviting me. Thank you, Shivani ma'am, for inviting me. Thank you. Thank you. Thank you.
Thank you,
sir.
Thank you,
sir.
Indu.
Thank you so
Thank
much,
you.
Thank you,
sir.
sir.
Happy
Sir,
birthday,
again, we
sir.
are going to meet on Friday.
Yeah, we are going to meet on Friday. Now, Tanushri ma'am will
Friday.
continue.
Yeah, yes, sir.
Okay. Okay. Fine. Thank you.
So we'll be having our next session from 3 p.m. onwards. There is a break of 30 minutes, almost 20 minutes. So I request all the participants to stay connected, have a short break, and then come back at 3 p.m. sharp. We'll be having another session with Tanushri ma'am. Thank you. Good afternoon, everyone. Um, Tanushri ma'am.
Yes, I'm there.
Yes, ma'am, you're audible. Um, so I hope all the participants have joined. We have 70 participants, 69 participants. We request you all to please join. We're about to start our next session for the day. All right, we can start the session. Indu ma'am, can we start?
Yes, ma'am.
Okay. Welcome back and a very good afternoon to all of you once again. And it is the second session of the day this on machine learning for research. And the session will be taken by Dr. Tanushri Bhattacharya ji. Let me brief about our expert's profile. Dr. Tanushri Bhattacharya ji is currently working in the business analytics department as an assistant professor at KG Somaiya Institute of Management. She has pursued her PhD in data sciences and has completed her postgraduate from the University of Mumbai. She is seasoned professor, excellence in business analysis, data analysis, and data science. As a certified data scientist and business analyst, she embodies a commitment to continuous learning. Proficient in Python, R, Tableau, and Power BI, she transforms complex data into valuable insights. Her expertise extends towards neural networks and advanced machine learning prowess. She has made a significant impact in education, teaching students and professionals alike. Her career spans diverse roles from co-founding and being COO at Cognito Knowledge Tech Private Limited to showcasing adaptability and visionary leadership. Her multifaceted journey epitomized a dedication to personal and professional growth. Over to you, Tanushri ma'am. Welcome. And I request all the participants to keep yourself on mute throughout. If in case of any query, you can raise your hand for that. Thank you, ma'am. Please continue.
Okay, good afternoon, everyone. Uh, so yeah, as ma'am introduced so I'll just give you a brief. So yes, I am associated with business analytics department. I have been a data scientist, worked on a lot of projects. I have been training in machine learning and all to in corporates and all. But the topic given to me is machine learning in research. So to begin with, just let me know if my screen is visible once I start sharing. I think yeah. Is my screen visible?
Yes, ma'am, it's visible.
Yeah. So throughout the session, I would like all of you to interact with me. At any point of time, if you have any difficulties, any queries, you can ask me. It is going to be a complete hands-on session where I will teach you a lot of things, any inputs, any doubts, any issues if you face. So the session I have divided into, first I'll introduce you to the concepts. Then I have planned to take 2 to 3 algorithms of core ML based upon one particular data set. So today my session was actually on Thursday, but it is now divided into 2 days. So today I will complete the first half that I have planned, and the next half I will be covering on Thursday. The things will be connected. You will come to know as and how we progress. Okay. So as the topic says, machine learning. Machine learning is one of the hot topics which is going on in the industry. So anyone would like to just tell me, like, if anyone has worked on machine learning or did any or worked on any algorithm machine learning, done any research, done any project? Anyone would like to share their experience? In the chat box also you can write. Okay. Miss Padma, yeah. Can you tell me on which algorithms you have worked? Or which tool? Okay. Yeah, so when we talk about done a content analysis using NLP, okay. How many of you have worked on Python? Just give me a thumbs up in your uh, in the chat box. California housing data set, okay. So I have planned to deliver or to make you do hands-on using Python. Okay, I'll try to make the session as interesting as possible, as interactive as possible. Provided you people interact, you have to unmute yourself and interact. So I think Miss Jyoti Sharma, your camera was on. So you can just go and sit in front of the laptop and start doing whatever we are planned to do. Anyways, so as the topic suggests, this is machine learning, fundamentals, algorithms, and research application. So I am going to connect the concepts of machine learning to how you can correlate it with with research, and where you can use it, how the algorithms you can use for doing your research. Or when I talk about research, it not only involves application of an algorithm, it majorly involves on the interpretations of the algorithms. Okay, so when I'm going to go ahead in teaching you the concepts of algorithms and as well as doing the programming, I am going to focus more upon the interpretations, because when you are writing research papers, that time how you interpret the results, your conclusion sections and all, that becomes a major part, as well as how you describe the data that you are going to use. Now when we talk about machine learning, the common jargon machine and learning, it means that we are making our machine learn. Okay, now learn what? So the concept of machine learning came from where we wanted to automate things. We wanted, the data was becoming huge to handle, and we wanted to have processing systems wherein once the data is fed, once the data is fed, we can process that information, and the output or the inferences or the insights can from the data can be automated. So if I just talk about this picture which is given over here, we can see that this is an ordinary system with the implication AI is everywhere nowadays. So AI, machine learning, all these applications help us to do basically these particular things which are listed over here. It first helps the machine to learn, moves. So I'll just give you an example. I was doing some R&D on a place where I want to visit in a month or so. I just googled the flight tickets and all, and the moment I went on my Instagram account and my Facebook account, I started getting recommendations and notifications of the popular destinations that I can visit once I am on that place. Okay, so this is how the machine learns. It's just I googled my flight tickets just in the morning, and in the evening, since till the evening, I started getting all the recommendations. So this is how we are, the systems are so fluid now, where they are learning and making it more adapting to the people who are doing their research or R&D on the forums. Okay, so that's what is machine learning. So it enables the systems to learn from the data. It enables predictions, classification, pattern detection, automation. Used across various disciplines, healthcare, finance, education, sciences, etc. We are going to see a lot of application domains wherever we are using this. So now when I talk about machine learning versus traditional programming, so earlier, just imagine 10-15 years back, the software developers or the software engineers used to develop systems. They used to develop an application, okay? But ML goes beyond that. ML is sitting on top of those applications built, where they understand the people who are interacting with the system. They are trying to find out the patterns of interaction with the people amongst the people who are using the system. So that's what is learning. And what is happening after learning? Once they are learning, they are making their system robust so that we give the recommendations or preferences and choices to the people. The very first recommendation or the machine learning system implemented was by Amazon. When Amazon developed its recommendation system. So Amazon is 2 to 3 decades old company. So it was earlier a library. Then it went on to an e-commerce business, right? So when it went on to an e-commerce business, they wanted to expand. Now, how they would expand? So it is a very common problem is about a market basket analysis. The thought of ML started from there. That suppose if a customer buys bread, then preferably that customer can also buy butter or jam or eggs along with bread. So that's where they started matching the patterns. From there, it evolved to an entire domain of machine learning, artificial intelligence, deep learning, and neural networks. So that's what it is. The comparison is given over here that in traditional programming, there is to be explicit instructions. But in machine learning, the systems are developed in a way that they learn the patterns from the data. There is a fixed logic. We keep on developing the adaptable models. How we develop those adaptable models, I'll explain you when we go on to do in implementing the algorithm. Then there is a fixed logic. There are adaptable models. We set the inputs and rules, and based on the set inputs and rules, we get the desired output. But over here, we give the input, we know what will be the output, and we get the rules, or we build the models, and the models redevelop, keep on developing itself again and again based on the input and the output that we provide to the system. So this is the basic difference between machine learning and traditional programming. Now, when we talk about machine learning, the core domain or the cohort of machine learning is divided into 3 major domains. So the first branch of machine learning is supervised. The second branch of machine learning is unsupervised. And the most, we would say, the recent and the unexplored domain is the reinforcement learning. So when we talk about ML, people usually speak, okay, ML is supervised, ML is unsupervised. It's not only supervised and unsupervised. There is also the concept of reinforcement. So I'll explain you with one example in each. So when we talk about supervised machine learning, the supervised machine learning algorithms are divided into 2 major parts. We have regression and then we have classification. All of you, anyone who have done statistics or mathematics, those people know what linear regression is. So in regression, there comes linear regression, logistic regression, and various other regression techniques. Then we have classification. Can anyone tell me one application of each? Where regression is used or where classification is used? You can type in the chat box. No one? Okay. So regression is basically used. Okay, price, demand, stock prediction. Regression is for continuous. Okay. So it is when Ms. Padma, here you have written regression is for continuous numeric values. That is where this algorithm is used. I asked for a particular application. If anyone knows the application. So when I talk about regression is where we do predictions on numeric form of data. So when I talk about linear regression, it basically works on numeric or continuous type of data. Price prediction, like Musin has written, price prediction, demand, stock, all these are continuous numeric values for which we use linear regression. When we talk about classification is a broad domain. Okay, so classification, when we talk about classification, the data becomes very complicated. Okay, now Yes, Deepika, it's used for prediction. So when I talk about classification, it starts from a basic logistic regression till image processing, deep learning, neural networks. Okay, so when if I talk about logistic regression, it's just about prediction of yes or no, or suppose a person is going to get a loan or not, person is going to default a loan or not. And when I talk about deep learning or neural networks, it's about image classification, it's about blood sample matching, it's about voice recognition. Your Siri and all, your Google Assist, whatever you used, they recognize your voice, they match your voice. So all these starts with are implemented using the core complex algorithms like your deep learning, neural networks, and AI concepts. Okay. Now, when we talk about unsupervised learning is basically consisting of majorly clustering algorithms. Now, when I talk about clusters, so clustering algorithms are basically work upon where we have to give recommendations, your market basket analysis, like I talked about. So all these comes under unsupervised learning. When I talk about reinforcement, it is one of the most developing branch of machine learning. Where for the very simple example is your self-driven cars. So if you see the diagram over here, so reinforcement learning is used where I want my system to learn from the environment and redevelop itself. So every time whenever an automated car is on the road, it is learning and trying to rebuild its logic again and again so that it can learn from a new type of obstacle, a new type of a road denture and all those stuffs. So that is where reinforcement algorithms or learnings are used. So if you just see from the environment, the model agent, a feedback is given and an action is taken. So that is how a reinforcement algorithm works. Okay. So this is what is your supervised, unsupervised and reinforcement algorithms that are used in machine learning. Now, yes, benefits and limitations. Benefits are huge. It automates complex decision making, finds patterns in big data, increases accuracy over time. There are some limitations of machine learning as it requires large data sets. Its interpretability challenges because the people who are using this logic and concept should be aware and pro with the concepts of the algorithms so that they can interpret the results. And then risk of bias and ethical issues, that is obviously there. When we are building large data systems, your ethics and risk is always a part of it. Now, just some bifurcations and the names of algorithms which are linked with all these things. Under supervised, as we discussed, there are algorithms like logistic, decision trees, linear regression. Then unsupervised, we have clustering algorithms like K-means, hierarchical, PCA. Now, there is another important branch which is ensemble models. So, I'll try to cover one ensemble model for all of you. That is random forest, one of the fantastic algorithms of classification. So, while if we reach till random forest, then you will understand the need and the benefit and the usage of random forest that is there in the industry. Okay. So just a quick glimpse of all the algorithms. So when I talk about linear regression, so linear regression is governed by the equation y is equal to mx plus c. So when I talk about y is equal to mx plus c, your algorithm is actually used to do a prediction. Okay. So when I write the equation y is equal to mx plus c, and when we build the model, we are actually building it to do the predictions. So my equation is nothing but y hat. So it is y predict is equal to mx plus c. Okay. Now when I talk about logistic regression, if you see over here the diagram, my linear regression line is, just one second. So when I talk about a linear regression line, so this is how my linear regression line looks like, and this is governed by y is equal to mx plus c. Now when I talk about logistic Logistic regression is basically used as a classification algorithm, but in that the classification is always for two classes, either a 0 or a 1, or a yes or a no. Okay, so the y is always going to be binary. It is not that there are it cannot go beyond binary levels. It can go beyond binary levels, but when it go beyond binary levels, then that time it becomes multinomial. Okay, or ordinal logistic regression. So we are going to cover the simple logistic or multiple logistic regression today. So as I described over here, so this is how your linear regression looks like. But when I draw a logistic, my logistic regression curves becomes like this, which is a sigmoid curve. Okay, now when I talk about it being a sigmoid curve, there are chances that my output will only range in two extremes, that is a 0 or a 1. Okay, so if you go to a branch for taking loan, or if your kids want to take education loan, or if you want to buy or if you want to take a loan for your property, so they will do all the background check on your financial documents, and then they will take a decision whether this person is eligible for taking a loan or not. So there are only two options of output, that is a yes or a no. Okay, so when these type of decision making are there, logistic is one of the best fit algorithm which can be used in that particular scenario. So suppose you are doing a research wherein you have a data set and you want to take a or you want to run a classification algorithm where you have to take a decision on yes or no. There is only binary level of decision. So logistic is anytime a very good algorithm to go ahead with. Okay, now so over here I've given some examples like predicting likelihood of a disease, customer churn prediction, email spam detection, all these type, employee attrition. If you are from HR, you will know that attrition is one of the domain that comes under the HR. So if you want to study how or what is the attrition level, or if or given what conditions or situation a person will be retained or that person will leave, even in those conditions you can use this type of a regression method. Now suppose I give this example. So there are like our linear regression algorithm, there are multiple x and my output is just like I am happy or a sad. So my mood, if I want to understand the mood of a person or preference of a particular show, so there are two outputs, that is yes, I am happy after watching it or I am sad. Okay, now all over India the movie Sayara is going just gaga all over the places. People are just loving it because of the love story that is being depicted. So some people are just coming out of the theater being happy, some are just coming out of the theater being sad. Now happy and sad, these are the levels of emotions which I have targeted. But for this there are various independent variables which are being listed over here. So the people who are able to correlate to their love stories, and if they have faced some drawbacks or hardships in their life, then they are coming out crying and being sad. And if they are having a happy ending, then they are coming out watching the movie as happy. So who is influencing these factors or variables which are listed over here? I'm trying to correlate with very common examples so that you people can understand how X and Y are correlated or they have the relation with each other. So now who is going to or how this X is going to contribute to being happy or to being sad? So this X, X1, X2, X3 all are having coefficients. So the equation or your logistic regression equation also has something which is your y hat is equal to m1 x1 plus m2 x2 plus m3 x3 so on plus c plus e, which is the error term. Okay, now something interesting I'll just show you. So when I talk about, 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 so logistic regression. So my linear regression equation is given as my is equal to mx plus c. Okay. Now when I talk about logistic regression, this equation changes and the equation becomes your y predict or your y hat is equal to 1 upon 1 plus e raised to minus y. So the entire game of logistic regression is over here. So basically, and this y, when I talk about this y is nothing but this y is equal to m1 x1 plus m2 x2 plus m3 x3 plus c plus e, which is nothing but the linear regression equation. So this entire linear regression function gets on top of the exponential power of e. So that's why this entire equation gets converted into a sigmoid curve, which is represented like this. So in your linear regression, actually if you see, your curve is like, your line is like this, but I have to do some mathematical calculation to convert this line into a sigmoid curve. Are you understanding this logic? So when this sigmoid curve is achieved, this part becomes your 1 and this part which is near to the 0 becomes your 0. Okay, so I'll explain this in much detail once we go to the coding part, but for the basics part, for you people, it is necessary to understand how the linear regression equation gets converted into your logistic regression equation. So since this equation, that is 1 upon 1 plus e raised to minus y, since it is written like this, this becomes your exponential part. Okay, and this is nothing but your linear regression equation getting converted into your logistic. Okay, just introducing the other few ML algorithms. We have decision trees. Decision tree example also I will be covering, but I will cover that in the next session of ours. So when I talk about decision tree algorithms are also one of the powerful algorithms which are there in machine learning, and we use decision trees to again do classification, but it overcomes the logistic regression issue. So logistic regression has the issue that it can only handle binary or dichotomous classification, but decision trees can handle multiple level of classification. So in decision tree process, we practically build the trees and then we do the interpretations. So when we'll cover the example, that time also I will make you understand how from this tree you can make the decisions. Okay, and that will go as the inference or the result interpretation part in any of your research paper if you are using this particular algorithm. Now, when I talk about decision tree, so if you see the example, it's written, should I accept a new job offer? Okay. So if I talk about you, a person accepting a new job offer, what is the primary thing that the person is going to look into? The first thing that is going to matter is the salary, right? So the constraint that I'm going to set is that my salary should be at least $50,000. If it is, then I will check another constraint, that is my commute time should be, if my commute time is more than an hour or no from my home. If it is, now over here if you see, if my salary is less than this amount, then I'm going to decline the offer. If my salary, if my commute time is more than 1 hour, then also I'm going to decline the offer. If my commute time is not more than 1 hour, then I am going to see whether my company is offering coffee or not. Okay, so if my company is offering free coffee, then I'm going to accept the order, and then if it is not, then I'm going to decline the offer. Yes, Mohsin, it's almost like a flow chart, but it's not like the regular flow chart that we build for our algorithms that we write in our computer programming language. Okay, so if you see, the entire flow is divided into roots and nodes, if you see over here. So we have a top node which is called as the root node. Then there are various decision nodes, and the decisions are getting segregated at the decision node. Now your question is going to be, how are these decision nodes taking the decisions? That's where the concept of machine learning comes. So there are various different types of methods that are used to define this decision nodes logic. And that is the heart of your decision tree model. So there are 4 to 5 different methods based on which we use this decision nodes. So if you see at this decision node, it is basically a split node. So here the splitting logic works. So what is that splitting logic? That depends upon what problem you are having, what type of data you are having, and what is the result you are expecting. So this is how the split criterions or the decision nodes are divided. And then there is a terminal node. I hope it's clear, Mohsin. Yeah. So this is just one of the example. It is a very common example which I have taken. Like if you want to play tennis, okay. So if suppose a person wants to play, then there are some conditions which that person is going to look into. Suppose outlook. Suppose the weather outside is sunny, overcast, and rainy. Then if it is, then it is going to check whether there is humidity or not. If there is no humidity, then there are probable chances of me playing. If there is humidity, then there are probable chances of me not playing. If there is windy, then I will not play. If there is no wind, then I will play. So that's how the decisions are being taken. So this is just a very simple example, but believe me, real-time examples or real-time situations in your industry or in your research doesn't work like this. It becomes more complex. Now, the next one of my favorite algorithms as a machine learning expert is random forest. Because random forest is like it's like a magician. It can do classification algorithms, and it gives you very nice accuracy as well as interpretations and results. So random forest, I have just given a diagram over here. I'm not going to go into the much depth of random forest algorithm because I would need some time to explain the core concepts of random forest. So random forest basically comes under ensemble models, one of the very talked about or important branches of machine learning. Basically, it comes under classification. So it is ensemble of decision trees. It uses the concept of bootstrapping. Anyone knows what is bootstrapping? Any coders over here who work on Java, C, C++, Python? Python, it's okay, but either C, C++ or Java. Anyone who know what's bootstrapping? Okay. I think you people might have heard the name or the word bootstrapping. So when I talk about bootstrapping, it is basically dividing the task, a major task, into multiple subtasks, doing the processing, and then merge at the end. Okay, so that is the major crux of this ensemble model, that is random forest. Okay, so in detail we'll see when we'll do it practically in the next class. So it is this is your random forest is basically an ensemble model on decision trees. It is a bootstrapping. Its concept, its core lies in classification, and it is used to reduce overfitting. All these jargons we are going to see in some time. Overfitting is one of the major drawback of decision trees. Practically, when we will be coding in Python, that time I'm going to show you what is overfitting and how random forest overcomes it. Okay. Okay. So when I talk about decision trees and random forest, again, this table we are going to discuss once we practically do what is decision tree and random forest. Now, when I talk about research applications, there are a huge ML machine learning is like an umbrella under which lot of research applications are being taking place. It is used in healthcare research, detecting cancers, pneumonia, stroke, disease risk prediction. All these in all these places, in all these domains, we use machine learning. In why do we use in research? Because yes, it makes your model more enhanced, and most important thing is this is a very niche domain. If you are using one of these algorithms, high probability and chances are there that your paper can go ahead with a good publication. Okay. Now, in physical sciences as well as in environmental research, nowadays sustainable development is everywhere. So my PhD is basically in sustainability, is PhD in data science, and my domain is in sustainability in oil and gas sector. So I have applied a lot of ML concepts and algorithms in as a pure sustainability aspect in oil and gas sector. So you can use it in environmental research, physical sciences. This is just a roadmap how ML or machine learning has evolved. So if I just talk about in 1958, it was just a perceptron. Okay, the first neural net which was designed. And today we are at AlphaFold. Well, we are solving the protein fold program concept. Okay, now we are into more complex systems where we are developing neural nets and all those things for solving a lot of complex situations and problems all around us. Sorry. Okay. So I think that's all theory from my end. Yes, I'll share the presentation, Padma, but after the second part of my session. After Thursday, I'll share it. Okay? So till now, any doubts, any issues, or any questions you want to ask me? Because from here now we are going to go on to hands-on, where I will teach you how to do or how to implement an algorithm using Python. Please ask me if any doubts. You can write in the chat box. I can clear it. Okay. So I would just like to know how many of you have already worked on Google Colab? Yes, Padma, I'm just moving on to it. That's why I asked the question. How many of you have worked on Google Colab? Okay. So what I'll do is I'll just share the data set that I want to cover today. Okay, Jupyter Lab you have worked upon. Uh, okay, so the thing is I want to share the data set, but my chat box is not allowing me to share. So how do I share it with all of you? Okay, I think all of you are there on the WhatsApp group, right? So I have shared the data over there.
Yes, ma'am. Everybody has joined that group, so they will have a link from there only.
So I think Narmada Pujari has written no.
Oh wait, I'm sharing the WhatsApp link then.
Did you all get the data set with you? Okay. So what I'll do is I'll explain the code and the concept. So there is a WhatsApp chat link given to you all. Please join that and I will reshare the dataset again over there.
Narmada ma'am, please look. I have shared the WhatsApp chat link. Please join that.
Okay, so what I'll do is I'll just go ahead with the explanation. Those who are joining, I think you can keep resharing the dataset on the group so that they can download it for them. And any queries for doubts you can put on the chat box. I'll try to resolve it. So what I'll do is I'll first explain you the flow. Then whatever the code I have written, we don't have time to do write and type all the codes together. So first I'll explain you the codes and then I will share this code as it is over here. You just have to copy paste it and run it. Does that work? And I will also explain you the logic so that you people can understand, or you can just take a note of the logic or the things that I have planned to implement and the output that is being given by the codes. Okay. Now over here, if you see, so this is particularly what link you want, Miss Padma? Google Colab link I am not sharing yet. Yes, I will share. Don't worry. You will get all the content. Uh, so I'll just give you the background of the data set that we have used. So this is a breast cancer prediction data set. This data set is available on your this UCI. Okay. Now I'll just explain what we are trying to do over here. So there are various parameters. So whenever we or the doctors ask for a mammogram or a test for detecting whether if there is a tumor found or a mass found in the breast, so there are various parameters which defines whether that mass can be confirmed as a malignant or a benign. Okay, so over here if you see what is done, so features are computed from a digitized image of a fine needle of a breast mass. They describe characteristics of the cell nuclei present in the image. So the attribute information that is given to us is ID number, diagnosis. So there are columns. If I show you the data over here, this is how the data looks. Okay, so this is the patient ID. This is the diagnosis. M means malignant, B means benign. So there is a count which is radius mean, texture mean, perimeter mean, area mean. Likewise, there are 32 columns. Out of the 32 columns, these two are ID is not needed, and this is my Y. So I'm going to diagnose it as a benign or a malignant tumor. Okay. So this is my Y, and all these are my X or my independent variables. Clear, understood? Did you understand about the data? Please keep writing yes or a thumbs up, whatever, however you want to convey the message to me. Yeah. So now over here, if you see, so there are real valued features computed for each cell nuclei. Yes, Y is target variable. So the target variable for us over here is diagnosis. Okay. So what is going to happen now? That's what now from here I can explain the logic of machine learning in a much better way to you. So this is the data. So if I talk about this data, how many entries are there? If you see, there are 570 entries. That means there are 569 patient entries over here. Okay. Now 569 patients data. On this, I am going to build a model. So my machine is going to learn. My algorithm is going to learn from these data entries. So what is going to happen? Suppose I take this particular entry. Okay, so he says that radius, texture is this, all these parameters. If these are the parameters, then this particular patient has been detected as a malignant tumor. Now, if you see, the radius is around 17.99, but over here it is now 20.57. It has increased and still it is a malignant. Now, when you will see for a B, you will see that 13.54 and 13.54 is a benign. Now, when I talk about 13.54 and suppose 13.71, if you see, 13.71 is treated as, is being declared as malignant, and 13.54 is being treated as benign. Are you understanding? Such marginal difference of decimal, and the patient is being targeted as, is being diagnosed as a malignant or a benign, because it is not completely depend upon this particular variable. It is also depending upon the other 30 variables which my data has which my data is being made of. Clear? Okay. Now when this data is there, when all these X are there, we are going to see the effect of all the variables which are there in my data set, and I am going to train my model. Okay, so training is what? When if you have pets at your home, or talk about just your kids, if you have kids, the younger ones, we train them since they are kids, then since they are just infant. Okay, so when, as and how we are training, they are learning. As they are learning, their behavior is changing, enhancing. Okay, a 1 year, 2 year kid will not show that much of maturity or that much of enhanced behavior than a 18, 19, 20 years of a person, right? Why? Because the learning is huge. Within a span of 15, 20, 16, 18 years, the learning has become huge. Okay? So, and the factors from which the person is learning has also become huge. So this is the process of training. As and how my data increases, my training capacity of my data increases and my model becomes more stronger and stronger and stronger. Are you able to understand? Now, so Padma, why we divide it into train and test? I'll explain that. But as of now, we are talking about the entire data that we are having. Okay. So suppose I am having 569 data. This is my training data. On top of it, I am going to build my machine learning algorithm, which is the logistic. Okay. Now, when I am building this algorithm, what will happen after that? Suppose 569 patients are here. Now, I will do the next entry. Okay. Now, suppose the 570th patient comes to my clinic. He enters the patient ID. This is empty. I don't know whether to label that person as a benign or a malignant. But what I know from the test done, I know that these are all the parameters that I will get from the test. I will enter all these parameters and then I will ask the machine to now perform the prediction that if a new person comes with all these set of data, the test results give all these parameters, a new patient comes based on the model that we have built. Now you tell me whether I will detect it as a malign or malignant or benign. Are you able to understand the logic? Why it is called as machine learning? Please everyone answer yes or no.
Dr. Binod, please mute yourself. Dr. Binod.
Okay. So are you able to understand the logic of what actually machine learning is now? Now, as Priya, I think, yeah, Padma Priya told that we divide the data into train and test, right? So my question is why? Some set protocols are there. That's why we are just dividing into train and test. Yes, Padma, Priya, you only give me the answer. Why it is mandatory that we divide the data into train and test? Again, I'll correlate it with a very simple example. Your COVID vaccines. Okay. How much time did it take to come in the market? Your COVID vaccine took around 1.5 to almost around 2 years to get launched in the market. Okay. What were they were telling? The trials are getting failed. When the vaccine was supposed to get launched, they were telling that the trials were getting failed. Okay. So now the vaccine was being produced. Okay. Depending upon the attributes, the features, or the variables of whatever they have collected or gathered as the symptoms of COVID, they gathered those, they designed the vaccine, and then they did some testing, which were called as trials. Okay. So when they were doing those trials, what they should observe, that the effects, the COVID effects should get reversed. Okay. So that is what is called as testing. So when you are training a model, after training a model, you should test it, whether your training model is accurate or not. If your training model is not accurate, you cannot go ahead and do the predictions. People think that training is prediction. Training is not prediction. Training is where we are constructing, we are building. After training, we are doing testing to check whether my training model is good or not. Once my training model is being tested, then I can go on doing the predictions for the new data that is coming to our system. Now what happens when a new data comes in? Let's suppose over here I told that I am now going to take 570th patient, which is a new patient. So when I will take that patient and I will enter all the values, I will go back and check that this is the values which has been entered. With this value, whether it is matching or correlating with any of the nearest values in training, and whether it has been tested. If train and test both gives malignant result, then this patient will be classified as a malignant patient. If both gives malignant, both gives benign, then that patient will be treated as a benign. Is this clear, everyone? Are you able to understand? What is the meaning of training and testing? Why do we do it? Okay, so that's why we need to build the train data, and on train data we need to do the testing so that I can claim that okay, my model is accurate with respect to this much % of accuracy. Now you can go ahead and do predictions for the newer data. Now when I will enter the 570th entry over here, and once I give the prediction, now I can do the prediction for the 571th entry as well. That is how my data is, or my model is learning again and again and again and again and again. And every observation serves as a new observation for him, and he learns from every new observation. Okay, understood? So we'll go ahead with the Python part. So how you are supposed to launch Google Colab for those who have never worked on it. So you have to open your Google Chrome, log into your Gmail account, and over here just type Colab. So it will just give you this particular entry. So over here you can do welcome to Colab, and over here you can see it is a new workbook. I hope every one of you have got data. All of you have got the data set. Please write yes or no in the chat box. Okay, so this is how your Google Colab work page looks like. So you can rename your page by just typing over here. So you can just give breast cancer prediction logistic regression like I have given. Now here is where we write the codes. If you have to give some headings, then you can select this text, and you can just write text, and you can just press it over here. You will see that your text is being printed over here. This part is basically used for coding. Okay. Now, so here I have just written the data description that is there for your data set. Okay. I have written the stepwise explanation for the algorithm. Now what you're supposed to do is, okay, so for I think okay, so in whenever we are working in Python, we need to import certain libraries which will automate and which will help you to work. Okay, so when I talk about pandas full form is basically panel data set, panel datas. Okay, So when I talk about pandas, it is panel data. Panel data or pandas is basically used to call the Excel sheets or the CSV files that we want to import for building our model. Then we have NumPy, which is numerical Python. We have Seaborn. Then we have Matplot. Seaborn and Matplot are basically used for doing the plots or the visualizations. Okay. sklearn is the library which we are going to use to build our models. All these others I'll explain you in some time. So now you are supposed to import this. So first I will paste these codes. Just copy and paste this as it is in this particular tab. So with this plus, you can increase the code tabs where you can keep writing the codes. Okay. So just press one tab and write for text, these type of headings that you are supposed to give. For that, you have to press this plus text button. Okay. So, and you just have to copy paste it and press this play button. So this will execute your code. Okay. Any doubts, any queries, please write in the chat box. I'll resolve all your queries. So the next is you have to load the data set. I am also sharing this particular code with you. Now before you just copy paste it, before you run this code, you are supposed to do one thing. See, there is a folder button over here. Just click on this. You will get the content folder over here. Now in this content folder on the right hand side, you can see there is a button. There are these three dots. Just select on this and select upload. Now this is where I have saved my data set. So you have to select this particular file. Go to this particular link, select this file and just press open over here. Padma, just wait. We are doing everything. For pre-processing the data set needs to be loaded. So I hope till here it's clear. Now when you will run this, it will ask you to choose the file. So you can choose the file and your file will be visible over here. Now what we have done is that entire file that we have chosen, I have renamed that file as data. Now wherever from here on I am going to use this file, I am going to call this file with the name data. Is this clear, everyone? Now, so we are now going to first understand and do some cleaning if needed. Okay. So when I am doing this, so I am trying to find out, I will first gather the info. So when I am doing data.info, I am trying to gather the information about my data. What all information you will get? it is first going to give you how many data points are there, how many rows are there. So I'm having 569 entries. How many columns are there? Total 33 columns are there in my data set. So I have ID till unnamed 32. Okay. So if I talk about this, you will see that over here I have different data types. So my ID is of int, my diagnosis is of object. Object means character data. Okay. Rest all others are float. Float means decimal point data. Okay. Now after this we will run the command that is describe. So I'll just give this command also to you. So when you will have data.describe, it is going to give you the complete descriptive statistics for the data. So now descriptive statistics is possible for those data which are continuous, okay, which are numeric. So in my data set, this ID is not a numeric data. So ID has given me some absurd values, but all others are numeric data. If you see, it has given me mean, median, mode, the quantile ranges and ratios and all those things. Okay. Are you able to understand this? Okay, good. So you got all this output. Now the next is I'm going to check whether there are any null values present in my data or not. Okay. So when you will run this, it will give you, okay, for me the data is not defined. So null means I'm checking if any of my data value, any of my entries are left out or not having any value. Okay. So it is giving me 0. So my data is not having any null values. Okay. Now if you see this unnamed 32 is having 569 null values. So actually this is a dummy column. This is a useless column. We don't need it. So what I'm going to do, I'm going to drop this. I also don't need patient IDs for training my model. So what I'm going to do, I'm going to drop this. So this is the code which I have used to drop. So what is happening? So drop, I have given the command ID and unnamed 2. These are the column names, and drop it. Data.drop is the command which is used to drop. Is this clear? All till here with me? Yes, good. After this, now if you see over here, my data is having, after ID, there is a column which is diagnosis. Okay, but this diagnosis is a object, means a character data, because if I show you my data set, this diagnosis column is given as alphabet B and M. My algorithm is not capable, logistic is not capable of reading M or B. I have to convert it into a numeric value. Okay, so what I'm going to do, I'm going to do some modification, which is, now I'm going to encode. So M is malignant going to be 1 and B, that is benign, is going to be 0. Yeah. So this is a part of data transformation. So what I'm going to do, data diagnosis is equal to data diagnosis dot map. So map means I am going to check wherever there is M, map it to 1. Wherever there is B, map it to 0. Okay. So that's why this function is being used. Again, I'm pasting it. Just run this. Yes, you can paid code for null value, na? I have already shared in the chat box. I have pasted it again. Okay. Now, so this is some EDA that we are going to do. So EDA, data visualization, exploratory data analysis, whatever you can call. So first I'm going to do the visualization of my class distribution. Okay. So what I did, SNS is Seaborn. Using Seaborn, I am plotting. So I can see amongst my diagnosis column, 0 is benign and 1 is malignant. So I have around 352 count of people with benign values. And over here, I can see malignant, around 210 values of malignant. Yes, Arjot, you can ask the query. You can type or you can unmute and ask. Yeah, I'm providing you the code. Your question will be how you will write the codes, right? Just have patience. Let me finish the session on Thursday. On Thursday, I will give you all the shortcuts and trick. Yes. So we are actually, this is the world of AI, na? So don't worry, we will do everything. Okay. So this is one type of visualization that we are doing. So I'm just giving the code. Run this. No errors till now, right? With anyone? If you want me to go a bit slow, I can go slow. Okay. Now, what did I do? I plotted for the count of malignant and benign values in my column. Okay. Now, the thing is, it's my habit that I always, if my data set has columns which are continuous in nature or having numeric values, I always do a box plot and I always do histogram. Okay. So box plots are basically done to check for outliers, and histogram I specifically do to see whether my data is skewed or not. Okay. In logistic regression, there is your outliers does not have much impact, but if there are if the outliers are huge in numbers, then obviously treating those outliers always helps. Okay. Yes, extreme values on the positive as well as on the max as well as the mean side. So now I'll just give you this code. Just run this and see, you will get this type of a diagram. So these are the box plots that I have got. Did you all get this plot? All of you? Others? Minu, can you just copy paste your error in the chat box? I can just look into it. Yes, I'm going to tell you. Don't worry. See, while you are copy pasting it now, be very sure that in this for loop, this spacing is there. If this spacing is not there, then it is going to give you error. Just make a note of this. Okay, so shall I now listen here. Just understand how are we supposed to interpret the box plot. As I told you, when you are writing your research papers, that time interpretation of your results are most important than anything. Okay, so now if I talk about this, so this is which data? This is radius by mean. So if I show you this particular column, so this is radius mean. Okay, now radius, this data is radius mean, and I have plotted the box plot against the two values of my diagnosis, that is benign or malignant. So when a patient come, I want to check whether it is benign or malignant. Okay, now what is going to happen over here for this particular graph? If you see, so I'll just zoom a bit over here. Just understand the interpretation, everyone. Very interesting it is. Now, benign means what? Benign means I am not, the patient is not having cancer, or malignant means the patient is more prone towards getting into that particular zone. Now, when I talk about this radius mean, the size, there is a specific range of size which is defined by the doctors, that if it is beyond or more than this particular size, then we can label it as a malignant, then we can label it as a malignant tumor or something like that. Okay, now over here, what are we supposed to measure? This is the box plot. This tail over here, if you see my mouse hovering, is called as the minimum side of my data. This is the maximum side of my data, this upper side. My minimum range is somewhere around, so this is 0 to, this is, I can say from 0 to 10, then 10 to 15, 15 to 20, 20 to 25. Okay, so this is where my range is being given. Now, what is this minimum value over here? It is coming somewhere around 6 or 7. Okay, and my maximum value is what? My maximum value is somewhere around, I can say 16 or 17, something like this. Are you able to interpret this? Yes or no, guys? Yeah. Okay. Now, so from this box plot, yeah, minimum is somewhere around, we can say yes, 2 to 3, and maximum is somewhere around, this is 16 to 17. Now, this line which is there, this is the median of the data. So this median is somewhere around, we can say 12. Okay. So this is how your box plot is read or understood. Now, when I talk about this particular circle or this particular outlier, these are called as outliers. So these are called as outliers because these are beyond the minimum and maximum range of my data. Is this clear? So I would say that when a data point is this, if I say this is around 17, when my data point is 17, okay, this patient was treated as benign even though 17 comes under the range of malignant. Are you able to understand? Yes or no, guys? Just try to look into it. Okay. So, see, this range of data, won't outliers be the max and minimum values in column? Gurmeet, what is it? Please come again. So I'll explain this again. So on the y-axis, you can see that I have values from 10, 15, 20, 25. Okay. Now, so this started from 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. Right. Now just see over here. I am talking about this particular outlier, this particular box plot. Okay. So this particular box plots minimum value is somewhere around 2 to 3, I can say. This is 5 to 10, 2 to 3, 9. This is somewhere around, I would say 6 to 7. Okay. Now this particular, then after this, this is the minimum value. My maximum value is somewhere for this particular data is somewhere around 16 to 17. Okay. So my mean radius, how you are supposed to interpret this? Mean radius value when my diagnosis is benign is ranging from 6 to 7 to 15 to 16. First thing, with 16 to 17 with median value as 12. Are you able to understand this? Till here, is it clear, everyone? Now what will happen? Why means Padma, you can unmute and ask me. Because the graph is showing these values. Now, when I talk about these outliers, so these outliers is, this is 16. Suppose I say that this particular outlier value is 17 and 18. Okay. Now, when it is 17 and 18, these are treated as outliers. Now, what is the meaning of outliers? Outliers are extreme values for a particular data. These are extreme values. What is this data trying to tell me? That this 16 and 17, if you see over here, sometimes the tumors are being treated or being diagnosed as malignant. Okay. Even so, when it is treated as malignant, 17, if you see, it has, the median is near to 17 when a tumor is being treated as malignant. But when it is benign, Okay, the 17 value is treated as an outlier. Here your question should come as why. So just observe, I'm again repeating, observe the range of malignant. Malignant range is somewhere from, I can say, 12 to 26. So if my mean radius of the tumor is somewhere from 12 to 26, there is high probability or chance for the doctor to claim that this is a malignant tumor. Now over here if you see, when it is a benign, its range is ranging, the size of the tumor should range from 6 to 7 to 16 to 17 centimeter or whatever the unit they are using to measure. Clear? But यहाँ पे if you see, the outlier value is 17. So 17 value is also there in malignant. Yes, it's contradictory because other parameters are also affecting it. Now you are getting the point. So this particular value is contradictory because there are other observations and other parameters also which is needed to study. That is what this box plot is trying to interpret. So when you are going to write the interpretations, that time also these observations you have to understand and write it. Are you able to understand now?
Madam, can I explain what I understood from this graph?
Yeah, please.
Basically, what this graph says and what we explained, out of around 570,
569 records.
69 data, those who are diagnosed as cancer, their radius is range of 12 to 26. Okay. But
Its
there are
radius
some
range is
cases,
from 12 to 26. Yeah.
26.
Yeah.
But there are some cases where the diameter radius is above 16 also. Okay, which is the normal, not category of breast cancer.
Yeah.
But still their radius is above 17. So there
Yes,
are
absolutely.
exceptionals,
Ah.
and those exceptionals can be explained or can be understood by studying the other factor,
Other
which is not
attributes.
mentioned. Okay, sir.
Yes.
Okay, ma'am.
So that's why your data is always dependent upon multiple X. Okay. Yes, so that's why I plotted all the box plots. So that's why you are supposed to read and interpret all the box plots, and you have to find out the dependency or the relationship between all the variables that are there. So even if you see for this texture mean, so texture mean is whenever the graph or sonography or the imaging is done, it is on a grayscale. So if the tumor is hard, okay, so the grayscale is more darker. If it is very light or if it is a hollow type of a mass, then your texture is very light. So that is what is the texture mean. So that time if you see your diagnosis is benign when the grayscale is very low, like the image is or the texture of the gray imaging is very light. It is ranging from somewhere 10 to 25. But over here if you say there are values which are contradicting. But why? Because these parameters are also dependent on other values. But for us, the main important thing is to study the extreme values, because if you see over here the malignant if a tumor is malignant, there are extreme values where the texture mean is 40, means it is very dark. If you see the radius mean is beyond 25, it is near to 30, means the radius is very big. So all these parameters, that's why visualizations are used to understand the data visually, what your data is trying to say. Okay, so that's what is the box plot that we have done over here. After this, I always have the practice of doing a histogram to check the skewness. So if you see, there are some data which is very nicely following the normal distribution. Some data is having a right skewed. But again, skewness and outliers does not much affect your logistic regression. But if your data is highly skewed or if your data is having a huge number of outliers. So that time, if you're doing linear regression, then it is necessary for us to do the outliers treatment as well as your linear regression treatment, and then go ahead with the model building. Okay, but for linear logistic regression, it's just you should have an overview and then go ahead in building the model. Okay. Now it is the industry norm says that if you are taking a particular column or a particular attribute, individual attribute shouldn't have outliers more than 5% of your data count. There shouldn't be more than 5% of null values present in your data. So all these are mandatory industry norms that we always follow while we are building the models. I'll just take 10 minutes more. I think it's okay if I continue.
Yes, ma'am, you can.
I can, right? Yeah, so I will finish this topic. So all the interpretations I have given over here, when I'll share this particular document, you will be able to go through this in interpretations as well. Try to maintain or write this interpretation the way I have given it over here. Okay? Yes, Padma, continue. PCA is basically a clustering algorithm. It is an unsupervised learning. Okay. Now here we are doing our train and test split. So I will just give this code to you. Just run this, your data will get splitted. Run the other next code also. This is where we have first build our model on the train data. So we have built our training model over here. Done this much? Shall I go ahead? Nothing to explain over here. I have just splitted my data into train and test. Test size 0.2 means 20% of the data is being put in test data. 80% of my data I have put in train data. Okay. Now this is important. Just run this. And now I'll explain you what is the main logic of logistic regression or how the accuracy is being built. Did you run this? Just let me know in the chat box. Okay. Now see what is happening. So I built a train model. Okay. So what I put over here, X train and Y train. Okay. Now if I, 1 second.
Madam, how you developed this model, madam?
Means
X data. How you developed this model?
develop this model means
Like X equal to data, this. How?
this one. Okay. So what I have done over here. So X is equal to data dot drop diagnosis. Okay. So data is my entire data set. Now my Y is diagnosis, na? So diagnosis column is what is my Y. All other columns are my X. So from my data, I want to drop my diagnosis column. Apart from the diagnosis column, all other columns becomes my X value. and to y I will assign diagnosis from my data set. Got it? So depending upon this, I am now dividing my X train S test, Y train Y test. Okay, and I have given my test size as 0.2. So I am preparing my data for building the model. Now over here, in my logistic regression, what I have done, logistic regression I have called from sklearn, the library that I have imported earlier. I have given it to run 1000 iteration. The model will run 1000 times and then it will give me the accuracy. Yes, y is dependent variable, x is independent. So after that we are doing model.fit, xtrain and ytrain. So these are the fixed syntax for running any model. Okay, it will never change. After this is what is most important for all of you to understand and what is happening over here. Now see, in my train, so what happens is, just get this logic, it is very beautiful to understand. So I had my entire data set. Okay, so in my data set I had my y and I had my x1, x2, x3 dot dot dot. Okay, now what I am doing, this entire data set now I divided. Okay, so this has become my train data, this has become my test data. Okay, so what I am going to do, my data is having y and all the x's. Use in my train model, I am based on that train model, I am going to do some predictions. What predictions? Of y pred. Understood? So what it means that if I show you in my data, okay, so if this particular column, this is part of my training data. If this particular row is part of my training data, what does it say? Given all these x, given all these values of x, my y is being diagnosed as M, which is malignant. When I will train my model, I will see that based on that train model, for all these data values, what is the predicted diagnosis? Whether they have predicted M or they have predicted B. Are you understanding? Guys? Okay, so that's what is happening over here. Just understand. On my model, I am going to run prediction. Prediction on what? My training data on which my model is being built. Okay, so abhi I am going to compare कि actual value is M और model build करने के बाद the predicted value is being predicted as M or it is being predicted as B. Then what the logic does is, actual mein it is M and if it is predicted as M, my accuracy is 100%. But if it is actual mein it is M and if it is predicted as B, then it is inaccurate prediction. Understood? So that's what is this particular confusion matrix is all about. So confusion matrix gives you 4 different types of things. That is your true negative, false negative, true positive. Now what is true positive? True positive means if your actual data is malignant and it is being predicted as malignant. True negative means if your data is actual, your data is benign and your prediction has also predicted as benign. Okay, when it is true positive, when it is false positive means it was actually supposed to be benign but is being predicted as malignant, and the reverse. So in both the case, which is your false positive and your false negative, those are errors in your prediction. And your true positive and your true negative are the accuracy parameters for your prediction. So just look over here at the accuracy formula. Your accuracy formula is given as true positive plus true negative upon the total count of data. So for my training model, my accuracy came as 0.958, which is 95.8% accuracy, which is around 96% accuracy. Understood? Everyone? Yes. This is ML. Now you will understand it a bit much properly over here. So what I have done over here, see. So this is now I have done on VoIP-Pred. So I have my test data also. So before releasing it to the doctors and giving my ML model, the doctor, now you keep taking all the parameters and my software will tell you whether it is whether a tumor is malignant or benign. Your model, I have built this model. Your doctor will ask you, did you test your model? You will say, yes, doctor, I have tested my model on my data. So 20% data I kept for testing. So on that, you will see that I have done the testing. Now here you see, see what is happening. So 204. So 204, if I go, okay, so malignant, I converted it to 0, right? So if you see in 204, it is M, 0, and even the predicted is 0. In 70, it is 1 and it is predicted as 1. But over here, if you see in 238, it is actually 0. But my model gave me a prediction as 1. So here is my error. Are you able to understand this? So what I'll do is, till here I have accuracy, till accuracy I have given you the code. Odds ratio I will take in the next class. I will give you this. Just run this and keep. This is also the confusion matrix. So if you see in my test data also, my confusion matrix value is 70 and 39. So here also my accuracy is 95.67. Now why did I build this to accuracy? Train accuracy was how much? 95.8. Test accuracy is 95.6. So the norm says, or the thumb rule says, that there shouldn't be a difference of more than 5% between the train and test accuracy. So my train accuracy is 95.8 and my test accuracy is 95.6. So the difference between train and test accuracy is within the range of 5%. So my model is very good to go. Are you able to understand? Please, one or two people share your views.
Madam,
Yes, yes.
I have to say something.
Yeah.
What I am trying to understand here with your research thing, out of this 570 patient data you have collected, you have checked that there are some positive, like they have the breast cancer, and some they don't have the breast cancer. All these 30 parameters you have plotted it. Okay. And out of that 570 or 69, those who have positive, that means M, their specific you have taken, and that is a train data. Okay, suppose you are taking 20% of that as a train data, and you
80% is train data.
as 8% train data.
20% is
means,
train data should always be more than test data.
Okay, so out of 569, 80% is your train data.
Train data, yes.
That means they have been proved that if this is a parameters, then it is the B. Case
Yes.
of B, case of M.
Yes.
Correct?
Yes.
And for the rest, data you put, whether the similar nature of a figure is coming, whether it is showing as M or B. If it
Yes.
is showing as M, then your prediction is correct. Your
Yes.
model is correct. That
Hmm.
is the basic concept.
Yes. So
Okay.
yes, you are right. So in train data also we are doing the same prediction. So train data, what we are doing, my actual data is M, and when I am building my model, if my model is also predicting whether it is M or not. So whenever there is a right prediction, it will increase my accuracy. If there is a wrong prediction, it will decrease my accuracy. Understood? So for any of, whenever I am building a classification model, the metrics to check accuracy is the count of true positive and true negative. These diagonal values over here, if you see, the true positive and true negative values should always be more than the false positive and the false negative. The जितना वो ज़्यादा होगा, that much more your accuracy will always be. So now this is trained. So I am building my model. After that, I want to test my model na, before launching it. So any software when you build, after developing, there is a testing phase. So using the test data, I am doing that testing phase. So in my testing phase also, I am creating the accuracy. That okay, now test data, the data that I have taken as test data, that is also part from the main data. Na? So on that test data only, based on the model that I have developed, that is the train model, I am testing. And then again I am checking on the test accuracy also. That okay, this is my original data and this is my actually predicted data. If they both are matching like it has over here, if they are matching, then my accuracy is increasing. If my matching is not happening, then my accuracy is decreasing. This is an error. So likewise, if you see over here, it is given. So here also you can see this is your true positive and true negative, which is higher, and this is on a lower scale. That's why my accuracy is high. No, fine tuning is not needed. Yes. Any doubts? Anyone, please? It is ready to be implemented. Yes, it is ready to be implemented. I think I already took 20 minutes more. But are you able, all of you, please give me a honest feedback, because ML is difficult. It is tough, but it is not that tough that you cannot do. And more tips and tricks on how to implement all this in Python. Padma, I'm going to share this link on Thursday. I told you already. I will give you all the content and notes. I will give you on Thursday after the end of my second session. So hope the session was informative to all of you. You learned something new. Yes, I think Dr. Shivani.
Any queries?
Next session, we will do some more interesting and amazing examples. So please be ready. The session will be more intensive because I have targeted to teach 2 more algorithms which are on a tougher side, but still it will be interesting for all of you.
So, ma'am, I don't think any more questions.
Yeah, I'll give you some data sets to practice. Don't worry.
Thank you, ma'am, for the highly engaging and the informative session on machine learning. And we truly enjoyed it and eagerly waiting for your next hands-on session on Thursday. Thank you so much, ma'am.
Okay. Thank you. I'll share all the content and notes on Thursday after my session. Okay. Thanks. Bye, guys.